Hey everybody, Shawn here from the automationblog.com. And in my expanded product coverage, today I'm featuring on the show a video sent in by John over at Siemens, in which he walks us through all the steps you need to create an S7-1500 project, to read in the existing I/O configuration from the field, and to connect it up to an HMI, which I haven't done that yet here with my setup, so I also found that very interesting. But in any case, I hope you enjoy this video. If you use Siemens, you should find it very helpful. If you're an Allen Bradley user, then this is a chance to see how the other side lives. But without further ado, here's John video on how to set up and configure an S7-1500.
I'm going to start with creating a fresh new project, automation project for all of our automation devices inside TI Portal Framework. And we'll start here in the portal view, basically the kind of getting started view, and actually add a hardware device, configure a device, and we're going to start with a PLC. So we just select a device. You can see the dialog gives us all the options for our automation, whether it's a project in the controller, program in the controller, HMI, a PC system, or in the drives. And then I basically have the option of selecting a specific hardware device. For this demonstration, let me go ahead and do an unspecified device, and we'll detect the actual hardware that's sitting in front of us in the kit. And it is firmware independent, so I can select different firmware revisions within this version of the software. We have that compatibility support. And I'll go ahead and open the device view so that we open up into the project view or the editor view of TI Portal and begin the editing process of the controller. And in our case, let's go ahead. We could start writing some program configuration, but let's go ahead and detect the hardware that we're sitting in front of, the PLC and the I/O and anything that's associated with that local chassis. And we'll read that directly into the engineering framework directly from the hardware and get the proper revision levels of every one of the components and come up with a default naming for the PLC, the digital inputs, and the analog. And then we can configure a couple parameters of the hardware devices, such as enabling a clock byte. So we have some kind of cyclic information rolling in the PLC as a reference as we add the HMI. Just an easy way to get a tag that's toggling through some strange states. And let's turn on some system diagnostics. Go to the analog module where we have a pot on the kit wired, and we have the opportunity of doing an overflow. So we change it from a template diagnostics, and we turn on some diagnostics flags to capture anytime there's a fault on that pot as far as an overflow. And then we'll just go ahead and compile the PLC or download both of those. We'll do a compile. And if there's any errors, it will be notified that there's an error in our configuration. First step, identify the hardware device that we want to target. And then hit download. It'll run a compare of what we have offline to online and make an effort. And here we do have an error in our configuration. And what's nice about this compile dialog is it leads us or directs us directly to the error. In this case, we have a safety PLC where it wants us to put a password, but we'll go ahead and just select no password. And then we select the hardware again and download again to the hardware from our engineering framework into the actual PLC, and download those configuration changes of that clock byte and that system diagnostics, and basically enable a happy running PLC. So after the download has completed, we'll start the module to put it into run mode. So it's on the pop-up or the second dialog of the window. And then we go online with the engineering software so we can see the status of our online devices. And green and orange indicate online and good status. So you can see we have a really good running status of our PLC, and you would see that if you're looking at the PLC, solid green lights. But when I turn that pot up beyond 10 volts and get an overflow, I'll get a diagnostic. And I can look at it in the engineering framework here directly on the module and get that exact specific system diagnostics without writing any logic, clear, simple text. And then I can also bring all of the diagnostics out of that controller because it's basically an alarm server, and just read those into my engineering framework with the diagnostic and the alarm display here shown with the bringing that in there. So that's how simple it is to basically configure a controller inside of an automation project and set up some properties so we get some automatically generated system diagnostics and download that into the PLC and get it running. Let's go ahead and go offline and link an HMI panel with some functionality. Again, the same add dialog. Now I've got the option of other automation devices such as the HMI. I'll go ahead and select the device that we have in front of us, which is a TP touch panel, 700 or 7-inch. Again, revision independent. I can select multiple versions there. And then it'll go ahead and give me a little pop-up to wizard through a standard setup for the HMI. This is kind of a beginner's opportunity to kind of see how the framework of the HMI can be set up. Best recommendations are build your own templates. We have an HMI template class where we provide some very powerful tools for templating your own HMI. And we will provide that workshop and more information on that later. In this case, I'll just create an IO test screen. The diagnostics are automatically going to be populated in the system screens. And I'll just go ahead and select all these things to build the worst case example of what's possible for a complete HMI, and then hit finish. Now this HMI is currently independent. It has no tags and no PLC connections configured. And that's why we use that clock byte from the PLC. We'll just drag that in directly from the tags on the PLC over to a screen on the HMI, and it'll automatically create a view to that tag as it cycles through while the PLC is in run mode, and it'll build an automatic connection of everything required between the PLC and the HMI, including basically the system diagnostics once we configure that. And again, here's the screens that we kind of set up as a default in our wizard, and then the global screen happens to be where those system diagnostic screens will be configured. And we enable some properties within there. And then basically, if we launch the HMI, here we can see the significance of being able to view the HMI as it's connected on the hardware. And we've got that diagnostic, that system diagnostic automatically generated on the HMI. So you see that same high limit from that analog input basically being fed directly to the HMI. And we have another view known as the system diagnostic view, where you can also delve in deeper to the status of all the hardware modules configured in the system under the PLC. So if I close that down, I cause the fault, you see animation being displayed on the hierarchy of the tree, and then I can navigate directly into the hardware module, and I get that exact same detail that I had in the engineering framework, now in the HMI with zero effort as far as configuring that in the program, because it's all done as part of the system.